on to lesson 3.2. Standard form of a linear equation is always ax plus by equals c, where a, b, and c are real numbers. So any numbers can be a, b, and c. Linear equations are equations that form, the word linear means line. Generally, your goal is to get it into slope-intercept form rather than standard form, which is y equals mx plus b. Okay, so we're starting out with graphing an equation. So there is not a set domain in this case. So step one is to solve the equation for y. So let's go ahead and start with step one. We have negative 2x plus y equals negative 3. So we have to decide what is happening to y and what do we need to do so that we can solve for y. Well, y is being added by negative 2x, or in other words, subtracted by 2x. So we need to get the negative 2x on the other side. We do that by applying the opposite operation. And we get y is equal, when you rewrite this, I always rewrite it with the x first and the constant after. Remember that the sign stays with the number or with the term. So let's make a table by choosing a few values for x and then finding the values for y. So now we're just going to pick a couple values that are going to be on our graph, a couple of x values that we can plug in to find out what the y values are and then graph them. I generally like to do negative 1, 0, and 1. So let's start with negative 1. If I plug in negative 1 into my equation, I get 2 times negative 1, which is negative 2, minus 3. I'm already in the negatives and I'm going further into the negatives. This is the same thing as plus and negative 3. So I'm at negative 5. Then step 2, or the next one, I would plug in 0. Y equals 2 times 0 minus 3. Well, 2 times 0 is 0, minus 3 is negative 3. And then the last one I'm going to plug in is 1. And in this case, I only really want you to find 3 points. Y is equal to 2 times 1 minus 3. 2 times 1 is 2, minus 3 is negative 1. So these are the points that you're going to be plotting on your graph, which is on the next page. So negative 5, negative 1, negative 5. We go negative 1, negative 5. Then we go 0, negative 3. So no direction in the x and the y, or in the x direction because it's 0, but then we go negative 3. And then 1, negative 1. 1, negative 1. Now if you did it correctly, it should result in a straight line. This straight line, since we do not have a domain, our domain is all of the x values, it's going to go on forever and ever, which means we need to put arrows on the ends of our lines. Now graphing lines y equals b and x equals a. These ones are rather simple. Anytime you have something like y equals a number, you're going to go to the y-axis. You're going to go to that number, so in this case it's 4, draw a dot, and you're going to do one solid line through that dot. Going the opposite way of the y-axis. And then for x, when x is equal to -3, you're going to do the same thing but with the x-axis. You're going to go to where x is -3, do your dot, and then it goes the opposite way of the axis. The reason it does that is basically it's saying that this equation, it is always -3. X is always -3. So, doesn't matter what y, it doesn't matter what y is. Y could be 1, x is still going to be -3. Y could be 6, x is still going to be -3. X could be -30, or y could be -30, and x will still be -3. So, y equals b, you're always going to have a horizontal line, okay, where b, at b, and x equals a, you're going to have a vertical line at a. Sometimes we will get functions that we will ask you to graph that will actually have a given domain. So in this case, we have an equation. Y equals -1/2 x plus 4. Okay. Well, step 1 is to solve for y, but in this case, it's already solved for y, so I can move on to the next step. Step 2 is to create a table. This table though has to go with this domain, which means I am not going to put points in my table that are less than 0, okay, because it says x is greater than or equal to 0, which means it can equal 0, so I'll probably plug in 0, and then I can plug in any other numbers above 0, okay. In this case, I'm going to stick with even numbers, and the reason I'm going to do that is because I see I'm going to be multiplying by 1/2, and if I keep these even, that will make it easier to multiply by 1/2. So we have -1/2 times 0 plus 4, that's going to be 4. -1/2 times 2 plus 4. Well, -1/2 times 2 is -1 plus 4. -1 plus 4 is 3. And then for 4, -1/2, 4 plus 4. Well, 1/2 of 4, -2 plus 4 is 2. So now we are going to graph these points. But remember, x has to be greater than or equal to 0. So it's all going to stay on this side of the graph where x is greater than or equal to 0. So we have 0, 4, 2, 3, and 4, 2. When I connect my line, I'm not going to be going this way because remember, our domain only exists where x is greater than or equal to 0. -1 is not greater than or equal to 0. -2, -3, etc. Now we want to identify what is the range of this graph. Well, we can go from anywhere down here all the way up until, well, it looks like my graph is going to stop at 4. So it's going to be -infinity to 4.